Good morning and welcome. Today we are going to be learning the last segment of quadratic equations, which is finding the roots of quadratic equations using the graphical method. In this class, we are going to revise the four methods for finding the roots of quadratic equations. We are going to learn to plot the graph of a quadratic equation, and from that graph, we are going to learn how to find the roots of the equation. And finally, we are going to solve examples. So, the four basic methods of finding the roots of quadratic equations which we have been learning in previous classes includes method of factorization, method of completing the square, and method of quadratic formulas. These three methods we have already learned about them, and the link to the videos are in the description of this video. And this video we are going to be learning the graphical method. So without much ado, let's begin. Graphical method. Every function can be represented on a graph. When you have a function y equal to a function of x, it can always be represented on a graph. And the nature of the function depends on the nature of the graph depends on the nature of the function. When we have quadratic functions, it always has a U shape, either a U shape or an N shape. Now, if that U shape crosses the x-axis, then we have a root to that equation. But if it does not cross the x-axis, then there is no root to that equation. And the points at which that U-shaped graph or N-shaped graph crosses the x-axis are the roots of our quadratic equation. So, how do we plot the graph? Since we now know how to identify the roots from the graph. First of all, we have to choose a range of value which we believe the roots of the equation should be part of. Now, this is very important because if you plot your graph at a range that does not encompass the roots of the equation, you are not going to be able to use that graph to find the roots of the equation. So your graph needs to be close enough to the actual values of the roots. For example, if the roots of your equation are 1 and 3, and you plot your graph from 7 to 10, you are not going to be able to find the roots of that equation using that graph, except you plot a graph that includes 1 and 3. So it's always best before you start drawing your table to find out any value that is close. You can test, just put one value in to find out how far from 0 it is, and then put in another value. That's a way to find out what range to use. Another way to get that is that most of the time in questions, the range will be suggested to you. If a range is suggested to you in a question, use the range that was suggested. Finally, when we've gotten our range, we have to calculate the corresponding values of y for each of the chosen values of x. So if our range of values is -1 to 2, for example, then we need to find out what will be the value of y when x is -1, what will be the value of y when x is 0, what will be the value of y when x is 1, and so on. When we have gotten those corresponding values and plotted and drawn them in a table, then we need to plot our points on a Cartesian coordinate and use a curve to join the points together to get a curved line graph. Now, to solve an example, let's plot the graph of the equation 3x squared plus 7x minus 6 equal to 0. And in this case, we are given the range x from x equal to -4 to x equal to 2. And when we do that, we are going to find the roots of this equation using the graphical method. So our first step will be to find the table. Here you can see x equals from -4 to 2. We have the values of x, -4, -3, -2, -1, 0, 1, and 2. And the corresponding values of x at that point. Here at when x is equal to -4, 3x squared is going to be 48. X squared in this case is going to be 16. 16 times 3, 48. 7 times -4 will give us -28, and then -6 is a constant. So 48 minus 28 minus 6 will give us 14. -3 squared will be 9. 9 times 3, 27. Whereas Minus 3 times 7 will give us 21. 6 is a constant. So 27 minus 21 minus 6 will give us 0. And that is how we find the corresponding values of y for these values of x. Now that we have our values of x and y, the next thing will be to draw a Cartesian coordinate and plot it. As you can see, this is a U-shaped graph, and it crosses the x-axis at this point A and B. Now, for us to actually be able to tell the value of the root of the equation, we need to take a closer look at this graph. Here we can see that this line crosses the x-axis at exactly x equal to minus 3. So one of the roots of this equation is x equal to minus 3. However, in this case, we have the value of b being somewhere between 1 and 0, but it's not exactly half. We can see this is 0 0.2, 0 0.4, 0 0.6, 0 0.8, and 1. So this is in between 0 0.6 and 0 0.8. But it's not quite exact. We can't really tell exactly what value, but if we are going to approximate it, this should be approximately 2 over 3. Now, this is the problem with graphical method. It is not always precise. Of course, when it crosses at a value such as this, x equal to minus 3, it is easy to identify the actual root of the equation. But when we cross at a point like this, it can be very difficult to identify the actual value. It can be very difficult to find the approximate value. This is why graphical method is not always encouraged, except when absolutely necessary. So, if you are not asked to use graphical method to find the roots of an equation, I will suggest you use the general quadratic formula, as that is the easiest and also one of the most reliable and most accurate methods. So, from the closer look we took, we can conclude that the roots of the equations coincide with the points x equal to minus 3 and x equal to 2 over 3. Now that we've learned the roots of the equation, I hope you were able to learn something new today. I hope you'll be able to solve quadratic equations using the graphical method. Here are some practice exercises. Using your graphical method, plot the graph and find the root of the equation 2x squared minus x minus 6 equal to 0 and x squared plus 3x minus 10 equal to 0. In these cases, you've not been given a range of values. So you are going to have to find your range of values by taking arbitrary values of x. Try, for example, x equal to 0. See if that is greater than or less than x. You try x equal to 1 and see if the value increased or decreased. If the value decreased, then you try x equal to 2 and so on until you can find a value that is relatively close to x equal to 0. Then take your range of values from there, maybe 3, 4, 5 values, and plot your graph. Then find the roots of the equation. If you have any questions, feel free to contact me on the comment sections. Let's discuss this. Let's discuss more of this until you are sure you learn it, then solve the practice exam exercises. See you in class.